Hello. In this video, we will talk about the head development. In summary, we will focus on the development of the jaws and the jaw bones and tissues. I thought this would be a good starting point here, so we have a continuous story. Where are we? We are at the end of the second week after fertilization. That is the end of the first week after implantation. The embryo here has been implanted inside the wall of the uterus. This here would be the endometrium, and this is inside the wall. So the embryo here is implanted, and specifically we're talking about this guy here. By the end of the second week, mom is expecting the menstrual cycle to start, and probably she's suspicious that she might be pregnant. So this is the time, she misses one day, and then she decides to do a pregnancy test. So in pregnancy test, we talked about this before, we're looking for a hormone produced by these guys here, the in situ trophoblasts, called HCG, human chorionic gonadotropin, and that's what will come back positive, because it's telling me that there is an embryo. No, that's number one. It has been successfully implanted, and it had reached the stage of the two-layered disc. Where is it? It's this guy here. This is the embryo. Everything else is supportive of this two-layered disc. It's in two dimension here, so you only see two layers of cells. But if I flip it in the next slide, you'll see an actual disc. So I call this the lucky coin. So that, just to remind you, is that when we do the pregnancy test, we're looking for this coin, and because it's something happy, we call it the lucky, or I call it the lucky coin, to remind myself. Okay, so we have two-layered disc, and we have three cavities at this point. We have the amniotic cavity, which is this one here. We have the primary umbilical vesicle, which is this one, and the gestational sac, which is this one. Okay, this is not what we're going to be focusing on. We're going to just focus on that disc. The disc has two layers, the epiblast on the back here, and the hypoblast, which is this layer here. And then let's look at it. What do we see here? We see a coin, basically, that has two layers, like here. This is the epi, okay, and this is the hypo, okay. So if this would be the human body, where are the directions? Okay, do we have any directions here? We can basically assume that this would be the back of the embryo, and this would be the front of the embryo. Okay, but where are the other directions? Where's the head? Can we assume where the head will develop? Well, we can actually, even as early as this stage. If we look closely, and we didn't show it here, at the hypoblastic layer, okay, there will be a thickening on one side. Some cells are taller, and that thickening, that patch of thick cells, we call it the precordial plate. And excuse my bad handwriting here. So just by looking at this thickening of cells, now we have directions. We know that this side will be the head, because I forgot to tell you that the precordial plate corresponds to what will become the oral cavity. Okay, so just by showing, by this structure starting to appear, that tells me that this side will be the head, this side would be the tail. Okay, we call it the tail end. Okay, so also, if this is the head and this is the tail, then this far side would be right. Actually, it would be left, because this is the back, so this would be the left side. This would be the right side. So now we have directions. And the next stage is extremely important, because now it's as if you hold the disc from these ends here and you start to pull it apart. Remember that everything is growing, and when I'm saying stretch it apart or pull it apart, I mean that's a direction of growth that will take place. So the disc, the circular disc, is now an oblong, and you have the head side or the cranial end, and you have the tail side, which is the caudal. We talked about this before, and we talked about those structures. This is where the precaudal plate would be, and this would be the primitive pit and the primitive streak, and we talked about the migration of cells, so I'm not going to talk more about this. In short, the epiblast and the hypoblast will turn into 3 layers instead of 2. So the epiblast will migrate a lot of cells through that primitive streak into the thickness of that embryo, causing it to have a 3rd layer right between the epiblast and the hypoblast. Most of the hypoblast will go away or will not be as rapid in division as the other cells. And when we have the next stage, which is a 3-layer disc, we didn't actually show it. This is the first layer, this is the second layer, this is the 3rd layer. You now have the ectoderm, the mesoderm, and the endoderm. Again, this is not what we're going to be focusing on. I just want to focus on this side here, which is the what will form the head. We are still flat. We're still oblong and flat. What will happen next is extremely important. This structure that is used to be flat is going to fold on itself. How? Imagine that this guy here started to fold in this direction, and this direction, and in this direction, and in this direction. How? Let's say this is the structure here. Okay, now it started to fold this way, and imagine the other side this way, and this side this way, this side this way, just like you see in this image here. I cut the head off at this area just to show you how the folding takes place. It folds this side and towards this side, and it folds on this this plane, which is the tail, and this is going to be the head. So the flat structure or the flat disc is now 3-dimensional. Okay, instead of it was 2-dimensional almost, because you could basically put it flat on a table. Now it has a thickness, because as the cells are growing and migrating, these folds are starting to happen. So expect tissues to be, especially in the head area, tissues would be coming from both sides, from the right side expanding forward, and from the left side expanding forward in columns of cells. Both sides are trying to meet its match from the other side along the midline. Okay, and also at the same time expect masses of tissues to be coming from above the head forward. So what are we talking about? We're talking about this guy here. So these tissues that you see here, these columns or fingers of tissues, are coming from this side, and there are others coming from the right side, which you don't see. And now you have the fold coming from above. We call that the frontal prominence. And these guys coming from the side are called the pharyngeal arches. You already see the first arch, which is this guy here. This big one here is the first pharyngeal arch, and this here is the frontonasal process coming from the frontal prominence. This here is the head. Okay, I'm not going to talk about other structures. You can see a lot of structures here, but we're going to focus on the development of the head, okay, which basically is Finger-like processes coming from the right side, finger-like processes coming from the left side, trying to meet their matches on the opposite side. And at the same time, a frontonasal prominence coming from above. So notice that the head is tilted downwards. Actually, it's not in this model. It should have been tilted more down. Like this baby should be looking further down, okay? Like almost at a right angle instead of, this one is more obtuse, but it should be almost right angle. So the baby should be facing downwards more. Okay, we'll talk about this in another lecture, talking specifically about the pharyngeal arches and how they are organized. So to talk about the head development, we need to talk about this process here, which is coming from above, the frontonasal prominence, and we'll talk about the first pharyngeal arch that will form both the upper and the lower jaws. So if this guy looked a little bit towards its left side, so it's looking like left lateral profile, okay? So imagine that this here would be the nose, if this was an actual grown-up, okay? And this here would be the eye, where the eye will be, okay? And this here would be the upper jaw, okay? Let's put a smile on this face, okay? And this here would be the lower jaw. Okay, so what are we looking at here? We're looking at the frontonasal prominence coming from above, and the first pharyngeal arch divides into two processes. This would be the maxillary prominence from the left side. There would be a maxillary prominence coming from the right side right here. Okay, you don't see it. And the mandibular process would be on the left side is coming from here. The mandibular process on the right side is coming from here. Notice that the mandibular processes, they don't have any problem meeting each other in the midline. Problem is the maxillary process, this guy. Okay, it wants to meet its brother coming from the right side, but it cannot, because it's obstructed by this mass of tissue coming from above. This is the frontonasal prominence, and it's not just a solid mass. It has divided itself into fingers, okay, finger-like processes on both the left and the right side. We'll see this better in the next image. So these lateral processes that we call the first pharyngeal arch, divided into two processes on the right, two processes on the left, are trying to move forward or migrate forward, trying to reach the midline. In the mandible, it's easy. It meets each other in the midline, no problem. They fuse. They become a one arch that will become the mandible. But the maxillary processes, they are met by a different process, not its match, but a different process coming from above that will form the tissues in between, as we will mention. This is extremely important and not very easy to understand and imagine. This here is not really an eye. We call this the precursor to the eye. It's called the eye plastode. We will talk about this separately, the development of the eye later, but I just want you to notice that it's on the side of the head. It's not, it should be here in the front. Okay, you should see two eyes here, but you see only one because it's on the side. The other side is not shown to you. So in a very simple diagram, let me show you how these guys look from the front. Okay, so we're looking at the entire embryo, and what we're focused on is this area here. This is the head. Okay, this is what will become the head. And this here is the frontonasal process coming from above. These are the eye plastodes, okay, on both sides like a fish. And notice that the frontonasal process started to divide into two sides. There's like a groove in the middle, or as it's not dividing, it's as it's growing, it's pushing two frontiers, two sides. Okay, it's it's growing in two masses, not one. Okay, so that leaves off kind of a groove in the middle. But the important thing is notice the maxillary process coming from the left side and the maxillary process coming from the right side. Remember, they're coming from the back forward. They're growing forward. They want to meet each other in the midline like their sisters here. Down here, the mandibular processes actually were able to find each other right here. So they fuse pretty early, and they form a mass of tissue covered by ectoderm, and inside there's ectomesenchyme, which is coming from the neural crest. We'll talk about this in the brain development and related tissues. So in other words, the mandible has already fused or is fusing, but the maxilla is met by a different process that prevents it from fusing. So it needs to fuse with these guys if you're going to have a face anytime soon. So you have to fuse this guy to this guy, and this, need to have a mark like here. This guy needs to fuse with this guy, and this second one in turn needs to fuse with this guy, and then the number 3 here needs to fuse with 4 down here. Okay, let's see what I'm talking about in a better picture. So this is how it will look like, and this is what people have a difficulty understanding and visualizing. This is what the diagram that you'll see in a lot of books, and it's not the easiest to understand. So what are we looking at? We're looking at the embryo face on, like the embryo's looking at you. These guys here on the side are the eye placodes. They're facing laterally like a fish, but they are trying to move forward. Okay, how do they move? They're not actually moving. The tissues around them are growing, and that changes the relative position of the eyes to make them more forward looking. Okay, but what are we looking at here? We're looking at this guy, which is the frontonasal prominence coming from above, and it's showing these fingers. The edges of the process is not actually a smooth mass of tissue. It has those fingers. In other words, it leaves cavities in the middle. Okay, and this here will become the nasal cavity. Okay, this is the anterior nares, or the anterior nasal opening. You don't have a cavity yet. It's still a dead end at this stage, but it will become so. Okay, so let's throw in some names. If this here is the nasal cavity, so this would be the medial nasal process on the left side. This here is the lateral nasal process on the left side. Okay, this here is the medial nasal process on the right side, and this here is the lateral nasal process on the left side. Everything is coming from the frontonasal process. All of these guys are coming from this mass of tissue. In other words, it is not part of the pharyngeal arches system. Okay, so we're talking about something coming from above, basically driven by the growth of the brain within it. Remember, this mass of tissue is holding the brain tissue in it, and as the brain is growing, it's pushing everything downwards. Okay, and these guys don't have brain in them. They're actually trying to make you a face. Okay, so all they want to do is grow medially, but the median plane is already occupied by these guys, so they need to fuse with them, and they need to do it fast. So how do they fuse? They fuse along this groove here, and they fuse along this groove here. What do we mean by they fuse across a groove? We call it a groove when it stays open, when it fails to fuse. But if it fuses all the time, we wouldn't even care to name it. But since sometimes it doesn't, then we have to give it a name, because we have to call it something. Okay, so This groove here is called the buccal, because this here is the buccal cavity or oral cavity. This here is the oral cavity. Okay, so this is bucco-nasal groove. This one here. Let me point to it with another arrow, big one. Okay, so this here is the bucco-nasal cavity. Connects the, if it stays open, it will connect the oral cavity with the nose. Okay, with the nasal cavity. Then you have another one between the lateral nasal process and the maxillary process. We call this the nasolacrimal groove, or the naso-optic groove, because you don't have lacrimal at this stage. Okay, naso-optic groove, and we will come back later when we talk about the development of the face and talk about what will happen to this guy if it doesn't fuse, and what even after it fuses, what will happen to it. Okay, so these grooves will disappear. They should, they must disappear. How do they disappear? There's several molecular mechanisms that need to happen where the mesoderm will actually disappear, and the epithelium will cover that gap in between. Okay, and now you have fusion between this guy here and this guy, and between also this guy here and this guy. Also, these two need to fuse together along the midline. Okay, and then the same thing will happen on the right side, where this medial nasal process will fuse with the lateral nasal process, and the lateral nasal process will fuse with the maxillary process, and the maxillary process will fuse with the medial nasal process. If all of these happen successfully, you will have a continuous maxilla. You will have the guy here on the right side, the picture on the right side. Actually, I highlighted the palate, although we will not talk about the palate in this lecture. There will be a separate lecture for it because it's a little bit more complicated. I'm talking about the maxilla as a bone, okay? The maxillary arch, also the zygoma, the lateral wall of the nose. All of this is coming from the maxillary prominence. What about this guy in the middle? There must be a contribution, because you have tissues coming from the medial nasal process that will stay in the middle. They're not going anywhere. And if you have a continuous maxilla, this here is the maxillary arch. I'm talking about the bone, not the soft tissue much. Soft tissue is a little bit more complicated. So the bone here, which is the upper jaw, which you can see here, is not coming just from the maxillary process. It has contribution from the medial nasal process in the middle. So if I want to see it in the mirror, where is the contribution of the medial nasal process? Figure out where it is. It's actually this area here. This area in the front, which we call the premaxilla, and the primary palate. This part is called the primary palate. Okay, this part is coming from the medial nasal process. Okay, so it's basically the bone that carries the four upper incisors, the medial incisor, the lateral incisor on both sides, and all the way to the incisive foramen. If you studied the bones of the jaws, there's a foramen here, an important foramen with blood vessels and nerves coming out of it, called the incisive foramen. From this point forward, there's like a triangle almost that defines the area coming from the medial nasal process and not from the maxillary process. Why is it very important? Because sometimes fusion doesn't happen. And this is where you expect to have a gap along these lines. Okay? Can be a unilateral, can be bilateral. We call that alveolar cleft. Really difficult to reconstruct. Okay? So, upper jaw, finished. Lower jaw, very simple. The mandibular process from the left side met the mandibular process on the right side. Not a lot of complications. really rare to have any kind of fusion defects in the mandible. Okay, it was reported several times, actually about 60 some cases in history, but nowhere compared to lack of fusion that takes place in the upper jaw, as we will see in the cleft lecture. Okay, so again, another picture that shows the contribution when the head is now bigger. This is 7 weeks. The head is bigger. Tissues have pushed the eyes forward. You don't have any eyelids yet. The eye placodes are now developing into the eye globe. You have the lateral nasal process, the medial nasal process, lateral nasal process. You should have fusion here between the maxillary process and the medial nasal process along the bucconasal groove. You should have fusion here between the maxillary process or prominence, also called prominence, and the lateral nasal process. Okay, on both sides. If you have that fusion, you will have continuous upper jaw from left to right, and you will have adequate upper jaw, and not just the upper jaw, the lateral wall of the nose, most of it, the floor of the orbit, the zygoma, the zygomatic prominence, and the upper jaw. All of these are coming from the maxillary process. Okay, so in cases where you have deficiency in the migration of these cells or deficiency in the development of the maxillary prominence, expect problems in the zygoma. Okay, expect problems in the level of the eye, because the floor of the orbit will be going down, basically will be smaller, so this eye will be pushed down. Maybe the eyes will not be pushed medially as they should. They will stay far apart. Okay, we'll talk about this in congenital anomalies of the face. We call that hypertelorism, where the eyes are wide spread because they weren't pushed forward as they should, because the tissues around them were deficient. Okay, so after that, you want to look at the outside of the, basically the face. This is at 10 weeks. Most of should be all the bones should be fused at this time. There's one last thing that I want to remind you, that the skin covering the upper jaw, which is basically the upper lip, is coming entirely from the maxillary process. Even the midline is actually coming from the maxillary process. That's the skin that covers the upper jaw. The confusion comes where you see cleft lip. Usually it's lateral like that. Okay, it's not usually in the midline. It's usually lateral. Okay, and the confusion was, okay, if it's lateral, maybe we can go up here. Maybe it's actually coming from the medial nasal process, that philtrum of the midline of the upper lip, that part that has two lines coming down. It looks like it's coming from these guys, but actually research shows that the cells that make the upper lip are entirely coming from the maxillary process. But the confusion is, when the bone doesn't form, let's say the maxillary process doesn't fuse with the medial nasal process, the skin of the maxillary process doesn't migrate and cover it, because it's still not fused, and there's lack of migration. So still the cleft lip will be lateral. We'll talk about this in details in the cleft lip and palate lecture. My point here is, for any multiple choice question, the skin of the upper lip, okay, is entirely coming from the maxillary process. The medial nasal process contributes to the bone, to the primary cleft, to the primary palate and the four incisors, the bone carrying the four incisors, okay, but not the midline of the skin, okay, and or the mucosa. This is coming from the maxillary process. I know this is a little bit difficult to understand. Maybe it will be a little bit clearer in the cleft lip and palate lecture when we go over it in details. Eventually, that's what you're looking to achieve. And thank you for your attention, and we'll see you in the next video.